Hi, now we are going to discuss CodeChef 156 contest long queue question. The question says that social is a person who is standing in a line and his position initially is at n, and the line is described as an array, and say that array as A, and that array has n minus 1 size, right? Sorry, n size. And the array has n size and the last person in the array is social. So now what we have to do is there is a condition. Social has some wealth and all the other persons also has some wealth, and Sushil will be able to insult a person when his wealth is less than or equal to n by 2. Sorry, Sushil's wealth by 2. Let's consider Sushil's wealth as W. If it is W by 2, the person will be get insulted by Sushil and that person will be eliminated from the list. Let's do this with an example. Let's say it is 2, 5, 1, 6 and 12. Now Sushil is at the end, right? Now he can eliminate the person in front of him if he has the half the wealth of Sushil or even less. 12 by 2 is 6, right? If the wealth of the other person is 6 or less than 6, he can eliminate that person. And one more condition is given that he can eliminate only the adjacent person to him. That means if Sushil is here, he can eliminate only this person. If he is here, he can eliminate only the front person, only one person at a time. So how this example goes? 6, 12. As 6 is less than or equal to this condition, we can eliminate him, right? So Sushil will come to this position. That means 2, 5, 1 and 12. Now 1 is also less than or equal to 6, right? 1 is less than or equal to 6. So this person will also get eliminated. Now 2, 5 and 12. Even here, this person will be eliminated because 5 is less than or equal to 6. So 2, 12, and even 2 will be eliminated. 12 will be the wealth of the Sushil, right? So he will get into first position. We need to return this position as our answer. This position of our answer. Let's say we have 20, 5, 1, 6, and 12. That means the first person wealth is 20. That means Sushil can eliminate 6, 1, and 5. That means now the position of Sushil will be here, second position. So we need to return 2 in the output. How can we proceed this? First, let's see the constraints so that if the constraints are low, we can directly do a linear search, linear operation, and linear traversal on the array and do the operations. The given constraints are in the question are n is till 100 and array elements are till 100. So the constraints are less, so we can directly do the linear traversal. That means let's take W is equals to the wealth of Sushil, that is array of n minus 1. That is the Sushil is standing at the last position. And let's say the answer is n. That means the Sushil is standing at nth position, right? So let's take the position of Sushil as n. We have to reduce this position depending on the constraint. So let's traverse through the array from n minus 2 to 0. That means he wants to travel from the biggest position to the smallest position, to the nearest position, right? So we have to move in the front direction. Now we have to check a condition where array of I is less than or equal to W by 2, right? The wealth of Sushil is W and W by 2. If this condition satisfies, we can eliminate the front person. That means ith person. So if this happens, we can decrease the position by 1. That means he eliminated that person. If this is not the case, we need to directly break the loop. That is, if in this case, if we see if 20 is not less than or equal to 6, right? So here we have to break. Even here we have 100. If we have 5 here, we can't eliminate this person. He can't eliminate 20. So he can't go to the front persons and eliminate. So he have to stop it at this position itself. So at that position, we are breaking. After the whole loop is done, what will happen? We have to return answer, right? This will be the position. That means he is at nth position, he have to move to nearest positions as possible. What will be the time complexity for this? As we are using only one loop to traverse the whole array, this may traverse in the worst case n, right? So the time complexity will be n, and the space complexity will be constant because we are not using any extra space. Thank you.